Hi everyone, we're looking at nomenclature today. We did alkane nomenclature before, but now there's a few more functional groups I'd like you to be able to name. Mainly alkenes, alcohols, alkyl halides, and ethers. And that's because we're going to be learning about how to synthesize these, and it helps to know what they're called. Alright, so let's get started. And I want to acknowledge Andre Sturmanis, who wrote a great workbook, a guided inquiry workbook, and some of these molecules I did get from his workbook. So thanks, Andre, and I've just modified this slightly. So we're looking at alkenes, and alkenes are double bonded molecules containing a double bond, carbon-carbon double bond. There are some rules with that. We use -ene ending for alkene as opposed to -ane, so as in alkane. We choose a longest chain that includes the double bond through it, so that may not be the longest chain. So we'll see examples of that. Double bond gets the lowest possible number, so and you have to number through that double bond. If there's a ring, then we consider branching to determine who comes before who. And there's in terms of numbers, and if there are multiple double bonds, we use ditri, tetra, ene, for example. Don't forget E and Z when it comes to double bonds. So here's some examples. I'll work through these for you. So the first one is a 2-carbon alkene. So just picture your 2-carbon alkane as ethane. So this is just ethene. It doesn't matter who's 1 or 2, and you don't have to use that since it's just a straight chain. With this one, we want to use the rule here. If there is a ring, the double bonded carbon with more branching gets the lower number. So if you look at this double bond here, you want to call this carbon 1 and this carbon 2. Now if you remember, when we did rings before without double bonds, we wanted a lowest number possible to incorporate all the branches, so we would have called this 1,2 dimethyl cyclohexene. But because the double bond goes this way, not this way, we need to say that this is carbon number 2, not this one. So we choose this one as 1 because it's got this branch, as opposed to this one has no branch. We want the double bond to have the lowest possible number, so we call that 1. And then we have to go through the double bond, meaning this has to be 2, even though that will make this methyl group occur at a high number, at carbon 6. But because of the double bond, we have to do it that way. So this one is going to be called 1,6 dimethyl cyclohexene. And just to emphasize that the double bond is occurring at carbon 1 as opposed to somewhere else, I put cyclohex-1-ene, or you can put 1-cyclohexene if you want. For the next one, we want to choose the longest chain which incorporates the double bond, and also want the double bond to get the lowest number possible. So instead of numbering this with the longest chain, I have to include the double bond in the longest chain. So I have to go 1, 2, 3, 4, 5. Or I can go the other way and it'll still be a chain of 5. So that means that this part is going to be off of carbon 2. So this is 2-propyl. And then here I can choose to say 1-pentene or pent-1-ene. Either one is fine. Now normally we don't say 1 if it's, normally it's assumed to be 1 if we drop it. So I could just say 2-propyl pentene, and that should be fine, but sometimes it's nice just to throw it in there just in case. So either one is fine. And then in this example, it has 2 double bonds, so instead of ene, we say diene. So this is a kind of diene. That's going to be the ending. And let's number through this. So we want the double bond of the lowest possible number, so we need to go 1, 2, 3, 4, 5, 6, 7, or 6, 7 up here. And when you do this, you find the longest chain incorporating both double bonds gives you a heptene, but it's a diene, so it's a heptadiene. And then the branches is just going to be this 2-methyl. So 2-methyl heptadiene, but with all these carbons, we have to say where the double bonds are. So we have to say 2-methyl, 2, 4, because it starts at 2 and it starts at 4, heptadiene. And, oh, I forgot, there's an ethyl group here as well. So let's put all of that in the name. So this one's going to be called 5-ethyl 2-methyl hepta-2,4-diene. All right, and you want to check for E and Z in the name. So if you look at this double bond, it's actually got 2 same groups here. So there's no E or Z for this double bond. And then for this double bond, these 2 groups are the same. So there is no E or Z for this one. But if there was, it would be like R and S where we put the numbers in front. So we'd say like 2Z, 4E, and then in parentheses, and then dash 5-ethyl 2-methyl hepta-2,4-diene. So if we had E or Z, it would go up here. And if there's only one double bond, you just put E or Z right here. So you'll see that in the next example here. So these are for practice for you to go through. Try naming these, and we'll go through that in a moment. Go ahead and refer to these rules and these examples and give it your best shot. All right, so let's take a look at some of these. The first one, I've been numbering the longest chain. Want this to be at 1 because of the double bond. So it's 1-butene or but-1-ene. And since there's neither E nor Z because these 2 hydrogens are the same. Over here, I have a ring, and this gets 1 as opposed to this, and then I have to number through that. Then I have an ethyl group here and methyl groups here. So 5-ethyl 1,4-dimethyl cyclohex 1-ene, or 1-cyclohexene if you want to put the 1 in front. That's fine. For this one, there's a complex branch here, which I've shown in green. So I'll say that this is the parent. So it's a cyclopent 1-ene or 1-cyclopentene. And then the branch occurs at carbon 1 on the parent. And then this complex branch is a pentane, so it's a pentan 2-il attached to the parent at carbon 2. And then the last one is a diene, so it's a 1, 2, 3, 4, 5, 6, 7 heptadiene, 4,6-dimethyl 1,5 heptadiene or hepta-1,5-diene. So you could put 4,6-dimethyl hepta-1,5-diene is fine as well. And then there's sort of a joke. I have a mug at school that has this on it, and it's got like a little oxygen there, and it says, "Help me, I'm dying," because it's a carbon diene anyway. Not very funny, but I love that mug. All right. Okay, draw these alkenes. So here are some examples of names, and go ahead and try drawing the molecule out just to make sure you understand it both ways. Okay guys, and so we're back with this. This is a butene, so but-2-ene with a 2,3-dimethyl. There's no E or Z because these groups are all the same. Cyclopenta 1,3-diene, so 1, 2, 3, so to start double bonds at those carbons. And don't forget it's cyclo. And then here, Z means same side. And then pent-3-ene, actually there's a better name for this. Do you see that this is a mistake? This should be called pent-2-ene because you can count this way, not the other way, and get a lower number there. So this should be a 2 there. All right, I may have copied that from a question that said, fix this name. So Z, same side, and then pent-2-ene. And what if I wanted this methyl group down here? I would have to put E there, E for opposite or opposite side. Okay? Now we're going to look at what happens with halogens. These are basically like naming alkanes, but with a halogen in there. Let's go through some of these examples. 1, 2, 3, or 1, 2, 3, 2-chloropropane. So this is still our parent chain. So you want to use the longest possible chain with halogens, and then number the halogens as your lowest number if possible. So iodocyclopropane. So notice for the halogen names, you want to end the prefixes in O. So you have bromo, chloro, fluoro, etc., iodo. And then use the alkane as your ending. So propane chain, cyclopropane chain, a methane because there's only one carbon, a hexyne because this is an alkyne. So we end those in -ine. But you'll learn more about triple bonds next quarter, since we're only really working up through double bonds mainly. And then this is a pentane. So you can see those endings. So let's go through each one again. So this is 1, 2, 3, 2-chloropropane. We have 1-iodocyclopropane, or just drop the 1, that's fine, because it doesn't really matter where that iodine is, it's always going to be number 1. Dichloromethane, 2 chlorines on here. And by the way, this is also known by its common name, methylene chloride, and you might be familiar with that from lab. We use this as a solvent. Methylene chloride is a methylene group, is CH2. And sometimes dichloromethane goes by the acronym DCM. This one here, 1,5-dibromohex2-ine. Let's figure out what's going on here. So instead of starting the numbering over here, we have a lower number if we go this way. But also, it's a lower number this way because of the triple bond. So usually double bond and triple bond takes precedence over the halogens. So if there was a double bond here, we'd have to go this way, even though the bromine is at 2 versus at 1, going this way. So we do want the double and triple bonds to have the lower number, even if they're halogens. So halogen-wise, we want 1, 2, because the triple bond is 2 here, as opposed to going 1, 2, 3, 4 for the triple bond. So hex 2-ine is better than hex 4-ine. And then wherever the bromines end up, 1 and 5. That's fine. 1,5-dibromohex 2-ine. So the priority is because of the triple bond. We number it this way, not because of the bromine, actually. And then over here, a demonstration where there's a tie. We could have 2-bromo, or we could have 2-fluoro. And 2-fluoro is better just because there's 2 of them. So 2,2-difluoro, 4-bromo. If there's only 1 fluorine and 1 bromine, we would just use the alphabet and say 2-bromo. But since it's a 2,2,4, that'd be better than a 2,4,4. Okay, so again, very similar to naming rings where we want the lowest possible number combination. So this one is 1, 2, 3, 4, 5. Go ahead and take a moment and try to practice these. And I know we didn't cover triple bond, but just treat it like a double bond and use -ine instead of -ine. Okay, we're back. So let's take a look at this one. I numbered it 1, 2 because the branch right here. So 1, 2, 3, 4, 5. So 1,5-diodo with the 2 I's next to each other. Cyclopent 1-ene or cyclopentene. Here, 1, 2, 3, 4, 5. 5-bromo, 5-chloro, just alphabetically B before C. Pent 1-ene or pentene. 7, 7, 7. Wow, okay. 1, 2, 3, because I want this to happen at 3, not 1, 2, 3, 4, or 1, 2, 3, 4. So better to go this way because of the triple bond. That's what we mean by triple bond has priority over halogen. And good thing this is not at carbon 6, or we'd have carbon 6, 6, 6 trifluoro, but no, it's 7, 7, 7 trifluoro. So I want to number through this if possible, because it'd be harder to go this way and then think of a name for that group. I guess it'd just be trifluoromethyl something. But it's better to have more branching in the parent and a simpler branch out here. 777 trifluoro, 6-methyl hept 3-ine, YNE for triple bond alkyne. And then the last one is a little complicated here. This is a 2-bromoethyl group where you want the lower number attached to the parent if possible. So 1, 2, 3, 4, 5 gives me branches at 1 and 2, smallest numbers possible on the ring. So 1, 2-bromoethyl, and then 2-ethyl cyclopentane. Okay, guys, halfway through. So let's take a look at alcohols. Alcohols get priority over alkenes and halogens. And alkenes get priority over halogens. And halogens get priority over regular alkyl groups. So just know sort of the order of that. And here's ethanol. So this is 1 and 2. So you don't have to say ethyl 1-all, but you just have to say ethanol, or ethyl alcohol is a common name for that. Propan 2-all, 1, 2, 3. 2 is where the alcohol group is, or hydroxyl group is the proper term. And notice it's an isopropyl pattern, but with an OH here. So this is called isopropanol, or isopropyl alcohol is another way of doing that. Hexane 2,4-diol, so 2 alls, 1, 2, 3, no, 1, 2. So this way. So hexane 2,4-diol. This is like the dienes that we went over. This one is 1, 2, 3, 4, 5, 6. No, 1, 2, 3, 4, 5, 6, because alcohols get priority over alkenes. That means make the alcohol the lower number possible, even if you have an alkene in here. And then this one, cyclopent 2-ene, all. Okay, so what's going on here? So the ene is the double bond, and the all is the hydroxyl group. So this is a 2-ene. They're going to give that 1 because of the alcohol, 2, 3, 4, 5. And if you want, you can say 2-ene 1-all. You can stick a 1 between these two in order to really specify where the hydroxyl is. But because it's a 1, it doesn't have to be there. Go ahead and give these a try based on these examples. See if you can figure it out. Okay, guys, we're back. So this first one, I would number it 1, 2, 3, 4 as opposed to 1, 2, 3, 4. So 2-butanol is fine, or butan 2-all. Prop 2-ene 1-all for this one, because this has to be 1, 2, 3, so that's a prop. And then 2-ene 1-all. You want the alcohol to be the ending. This one is a cyclohexadiene, so you've got a 2,5-diene, and you want the 1 here with the alcohol group. So hexa 2,5-diene 1-all, or drop the 1. And the last one we have to number this way, and it's going to be 4,4-dichlorohexane 2-all. So I think pretty clear demonstration that we want to make the alcohol the priority, not the chlorines. Right, guys, for ethers, there are 2 ways to name this. So one is, think about the parent chain as an alkane. The longest possible alkane chain for this one would be 1, 2, 3, 4. And think of this as a group off of it. So this isn't an alcohol group, it's an alkoxy group. So this is a methyl group on an oxygen, is called a methoxy. So this is 1, 2, 2-methoxy, 3, 4 butane, 2-methoxybutane. The longest chain here is on this side, 1, 2, 3, so that's a propane, and you have a methyl and you have a methoxy, so 2-methoxy 2-methyl propane, or 2-methyl 2-methoxy propane, either one's fine. Here, longest chain is here. And then off of that you have this chain, which is an ethoxy. So ethoxy ethane for 2-carbon alkane. So that's thinking of it in terms of an alkane parent chain. Another way to think about it is just to look at one side of the molecule, name that, and then name the other side of the molecule, and just stick them together with the word ether at the end. A lot of people like this method, I think, because it's really simple. So you see a sec-butyl group here, and you see a methyl group here. So sec-butyl methyl ether, where B is alphabetized before M. Here you see a tert-butyl group on left side, a methyl group on the right side. So tert-butyl, using the B for alphabetization, and an M for methyl. Tert-butyl methyl ether. And by the way, I always tell my students, this is the gasoline additive called MTBE, methyl tertiary butyl ether. I guess they didn't know about the alphabet going by butyl, not tert. But in any case, they used to add this to gasoline, but now it's mostly banned because it's soluble in water. So even though it burns cleaner, as does ethanol, it's soluble in water supplies, and this is fairly toxic, so they banned that. This here is ethyl and ethyl. So instead of saying ethyl ether, we say diethyl ether. Or, because it's so common, we just call it ether sometimes. But there's many ethers, so it's always good to specify diethyl ether. Okay, so try these ethers, and as long as you know one way to name it, that's fine with me. But I do want you to appreciate and acknowledge that there are two ways, and if you're provided with one way, you should be able to know what that means, even though that might not be your preferred way of naming it. You should be able to look at either name and know what is being referred to. But for now, go ahead and just choose at least one way to name it, and then challenge yourself to do it both ways just in case. Alright guys, for this one, I put one naming system in purple and one in green. So methoxymethane, or dimethyl ether. Ethoxypropane, so this is my chain and the ethoxy group, and I guess I should say 2-ethoxypropane, and then ethyl propyl ether. This one is sec-butoxy, so this is sec-butoxy group off of a cyclopentane, or sec-butyl cyclopentyl ether. And then why did I choose cyclopentane as the parent? Could have chosen this as a parent and called it a cyclopentoxy 2-butane. But sometimes we go with the longest chain or the biggest, 5 carbons versus 4. So, but, sometimes you see there are exceptions to that, or it doesn't really matter sometimes. All right, and then here I have 2-4-methyl-pent-1-oxy. Ooh, it's a long one, right? So basically what I'm saying here is I want the longest chain, which is 6. So this is going to be my parent. So I have 4-methylhexane for that part. And then this as an oxy group is going to be 4-methyl-pent-1-oxy, or pentoxy, 4-methylhexane. And that's at carbon 2 that this whole big branch is occurring. So I put a 2- complex branch because of this stupid methyl group over here. Makes it so much harder. But I didn't really say stupid. I don't mean it. Sorry, methyl, I didn't mean it. 4-methylpentyl, that's this group over here, 4-methylpentyl. And then this group over here is 4-methylhexyl, or hexan 2-il. Why do I need to say that? Because it's attached at the second carbon, not at the first carbon. Like here, it's just right off of carbon 1, but here it's off of carbon 2. All right. Gosh, ethers, they're either easy or they're hard. Okay. All right. But it's fine if you prefer one system over the other. Everyone's different in what they prefer. But do know that if I tell you diethyl ether, you just got to know what that is. So please do practice recognizing either way, either method. And these are just for more practice problems. And of course, Brett Goldston has that great packet of nomenclature, which I will also refer you to, and find some practice problems in the book as well. Okay, good luck.